Lesson 1, Unit 11, Common Ions. We're going to look at common ions and acid-base equilibria. So the conjugate base of a weak acid is going to shift the acid-base equilibria. Consider a 0.5 liter solution of 0.10 molar HOCl in water. Here is our equilibrium expression. There is the value for Ka. If 0.010 moles of NaOCl is added to the solution, will the pH decrease, increase, or remain the same? Justify your answer. Assume adding 0.10 moles of solid sodium hypochlorite has negligible impact on the solution's volume. So what we are doing is we are adding more of the OCl minus. Consequently, we are going to see the reaction shift in the reverse direction to consume the additional OCl minus. The reaction shifts in reverse to consume the OCl minus. Hydronium ion is depleted, so the pH increases. Remember, the solution is going to become more basic. Okay, next we're going to look at what happens as we calculate what happens to the pH in the OCl minus solution. So we're going to write out a Rice table. We have RiCe, and we have the weak acid in equilibrium with H plus and the hypochlorite ion. Our initial concentration was 0.1 molar. We have initially none of the hydrogen ion and none of the hypochlorite. We are going to begin generating both products and losing reactant in a 1-to-1 ratio. Our equilibrium concentration is going to be 0.1 minus X, X, and X. Ka is equal to 3.5 times 10 to the negative 8th. We're going to assume that the initial concentration of HOCl is very large compared to X, so we can say that this is approximately equal to X squared over 0.10. When we solve for this, we will find that 5.92 times 10 to the negative 5th is our value of X, which remember is equal to our concentration of hydrogen ion concentration. We solve for the pH, and the pH is equal to 4.23. Okay, now we're going to calculate the pH after we add 0.10 moles of sodium hypochlorite to this solution. So what we need to do is figure out the molarity of the OCl minus. So we added 0.010 moles, and it was in 0.5 liters. So our concentration is equal to 0.20 molar of the hypochlorite ion. We'll set up our Rice table again with the equilibrium. We have our initial, our change, and our equilibrium. Our initial concentration is 0.10. Our hydrogen ion concentration is our answer from the previous problem, which was 5.92 times 10 to the negative 5th. Now remember, this is a very small amount, and our initial hypochlorite solution is 0.020. Because we've added the hypochlorite, we are going to shift the equilibrium in the reverse direction. So we are going to be losing X, and adding X. Since we are losing some from an already very small number here, our equilibrium concentration is approximately 0.10 here. We're going to designate this as a new unknown, y, so that things stay uncomplicated. This x here is much less than 5.92 times 10 to the negative 5th, so it also is going to be much less than 0.020. So we're going to say that this is approximately 0.020. This makes life much easier when we go to solve things, because now we have that 3.5 times 10 to the negative 8th is approximately equal to our hydrogen ion concentration, that's Y there, times 0.020 over 0.10. When we solve for our hydrogen ion concentration, it is equal to 1.75 times 10 to the negative 7th, and our pH is 6.76. Now, our original pH from above was equal to 4.23. So we can see that the pH does indeed increase as we predicted.